Okay, number 35. Yes, the one everybody always asks about
Would you
every
multiply
year.
that entire thing by x squared? Is that what you do? Or just move it to the top?
What is the first step of the differentiation process?
Rewrite.
Rewrite. Here's the thing. You do not have, until tomorrow, the rule to do this problem. So here's the problem. You only have, so far, you have the derivative of a constant. Everybody, derivative of constant is what? 0. The derivative of a simple power, x to the n is just n times x to the n minus 1. You have constant multiple rule, which is the derivative of a constant times the function, which is just the constant times the derivative of the function. You have sum and difference rule, which means you can take the derivative of addition and subtraction of terms, right? We have derivative of sine, which is cosine. Cosine, right? Professor Collins always said cosine. And then we have the derivative of cosine is negative sine. That's all you have right now. Okay, you're going to get more, don't worry. We're going to get a lot more, okay? Tomorrow we're going to get tangent, secant, cosecant, cotangent, and product and quotient rule. Okay, so you're going to get 6 more tomorrow. All right? You don't have a quotient rule right now. A quotient rule would be the derivative of something divided by something. All you've got is simple powers. So Mason is right in saying that we're going to have to simplify this quotient. So the way you can simplify it, the only time you can simplify a quotient is when it's divided by one single term. Let me clarify something here. If I put a plus 2 here now we got issues. We would not be able to do it now unless you can do long division or factor cancel or some kind of synthetic division, which we have to review because it's going to pop up here soon. Okay? So with that said, I can't do this problem unless it's a single term, which it does happen to have a single term, which is why it was in the homework assignment. Because I can do this one, because I can simplify this quotient. Now, here's the deal. When you do learn quotient rules, some of you are probably like, well, when I learn quotient rule, I won't do it this way. No, you'll still do it the way we're going to do it. Because quotient rule is longer. There is a benefit to learning how to do it with simple power rule. So all you have to do is take, and since it has a common denominator, you just need to imagine that, okay, f of x is equal to, every one of these terms is divided by x squared. So it's really x cubed divided by x squared. It's really minus 3x squared divided by x squared. And it's really plus 4 divided by x squared because they all have the same denominator, right? So is that legal?
Yeah.
And then you just simplify. So I haven't taken a derivative yet. So now I've got x cubed divided by x squared, which is what? X. Now I've got minus 3x squared divided by x squared, which is just what?
3.
Minus 3. And now I've got plus 4 over x squared, which is plus 4x to the negative 2, because I want to move it to the top, so I can use simple power rule. Now is it easy?
Yeah.
Now you just find f prime of x. Here we go. Derivative of x, special case, is just what? 1, derivative of a constant, 0, derivative of this, minus 8x to the what? Negative 3, final answer. F prime of x is equal to 1 minus 8 over x cubed. Now, I said there was another answer. There is another answer you can have. And I do want to warn you that on the AP exam, sometimes they do this just to be a jerk. Okay? What they'll do is they'll find a common denominator just to hide the answer from you. What's the common denominator? So you could make the common denominator. You could say, okay, this is 1 over 1, and then find a common denominator. So then f prime of x is really, well, the common denominator would be x cubed, right? So I'd multiply the top and bottom of this one by what? X to the third to get a common denominator. So then your final answer would be x to the third minus 8 all over what? So sometimes they'll do that and they'll put the answer back together, and just a bunch of flunks, but. No, I just look right away on your multiple choice. If you see this, if you see the answer we had first, 1 minus just 8 over x to the third, go with that. And if you don't, then be like, oh, they probably, just look at the answers. You'll be able to tell. If it's non-multiple choice, if it's free response, please just leave it like this. Don't do any extra time. Don't do a common denominator unless you absolutely have to. Does that help on that one? Does everybody see how to do 36 now? You do the same thing. You just divide it, every one of them by what? X, and then there you go. Okay, what else? There's got to be more. There just has to be. 47. Before I go to 47 and scroll to the next page, were there any here left? Any ones, the 23 through 30 or 28, I can. This one right here, number 28, wanted you to find the derivative and then find the derivative at the indicated point, 5, 0. So I've got f of x is equal to 3 times 5 minus x to the second power. All right, there's a reason you can't do this one right now, and that's there is a way to do this with simple power rule, but it involves what's called chain rule, which we're going to learn Thursday, Friday. That'll be your kind of your last basic derivative rule this week. We're going to get 7 rules this week, 6 tomorrow, 1 more at the end of the week, and then next week we'll get about 8 more rules. Okay, and then we'll be done with all our rules. That'll be it. Then we'll be all the basic derivative rules will be done in 2 weeks. Okay, so we got f of x equal to 3 times the quantity 5 minus x quantity squared. Here's the problem. This really is, if you look at this problem and expand it, it's really 3 times 5 minus x times 5 minus x. Now Max over here probably knows that there is a better way to do this problem, but you don't know how to do it yet until Thursday, Friday. It's called chain rule. But for now, here's how you would have to do it. We only have derivative of a constant. We only have the derivative of a simple power. We only have the derivative of a constant times a function. We only have the derivative of a sum or difference. We only have the derivative of sine or cosine. I have not talked about the derivative of a quotient. Neither have I talked about the derivative of a, starts with a P, product. Yes. You do not have a product rule yet. We will tomorrow. Okay, so for now, if you have a product, you're going to have to multiply it out. Now, this 3 is not a problem. If it's a constant times a function, we do have a derivative rule for that. Like if you have the derivative of a constant times a function, you've got a derivative rule for that because it's scalar multiple from a limit. The constant can just come out, and it's just going to be the constant times the derivative of the function. That's how we were able to do y equals 2 sine x. You didn't need product rule for that. Some of you are like, well, it's a product. Yeah, but it's a special product. It's a constant times a function. It's not a function times a function, really. Well, it is, because a constant is a function, but a constant's a special function where it has no variable in it. So if you have a constant, something with no variable in it times a function, you can just cheat it and say, I don't need product rule for that. It's just going to be 2 times the derivative of sine x, which is just what? Cosine x. That's how you did those on the quiz yesterday. That's how you did the trig ones. And I'll show you actually tomorrow. I'll prove this one with product rule too tomorrow, and you'll see why you get to shortcut it. Because you'll see part of it zeroes out every time. But this one you can't do that with. Because I have a function times a function, I have 2 things with an x in them. So, since I don't have a product rule, what's the only way you're going to be able to do this? What's your derivative process? Rewrite first, which means you're going to have to FOIL it. So we're going to rewrite it so that we can get it just to be addition and subtraction. So we're going to have f of x is going to be equal to 3 times, well, let's FOIL this. That's just going to be 25 minus 10x plus x squared, right? Then distribute the what? If you want. Don't really have to, because it's just a what? So I'm going to use constant multiple, my favorite rule. Forget distributing the done 3. I'll do it later. I'm going to go 3 times the derivative of this junk. What's the derivative of 25? 0. What's the derivative of negative 10x? Negative 10 plus. Then you can distribute the 3. Would it have mattered if I distributed the 3 first? Constant multiple rule says you can distribute it later or you can distribute it now. It's up to you.
Do you have to at all, or can you just leave it like that?
I would, in the final answer, probably most likely you're going to have to distribute it to see what the answer is in the multiple choice. Now, if you're on the free response, no, this is definitely fine. So final answer, I guess, would be negative 30 plus 6x, but I think you'll see that pretty easily. You're not going to stress out and be like, where is it? Oh, they got the 3 distributed. So there's your f prime of x. Did that help? So if you see any like that, like number 27, you're going to have to FOIL it first. So you're going to have to go 2x plus 1 times 2x plus 1. And then, now, the next part of this was to find the derivative at the indicated point. So after you get that, then what do I need? Do I need the 5 and the 0?
No.
Just need the 5. So it's just f prime of 5, which is going to be negative 30 plus 6 times 5, which is going to be 30. So what do you get? So this is the slope of the tangent line, which, ooh, that happens to be a horizontal tangent at that point. because the slope's 0. So at 5, 0, there happened to be a peak or a valley. I don't know which one. We'd have to graph it to see, or do a sign analysis, which we'll teach you later. Okay, anything else in that part? Okay, if I can answer questions for about 6, 7 more minutes, then I'll just real briefly show you the alternate form of a derivative for class today, and at 8 o'clock I'm going to be out of here. Always try and adhere to that. Just give you 20 minutes to get ready for school. Or what time do you start first hour? I don't have first hour all year, so that's nice. Love it. 52, I'd love to. Is this helping?
Yeah.
Okay, good. Because we're going to have a quiz tomorrow. I was going to have it today. You guys got lucky. Because I would have had it today. Tomorrow we'll have it at the beginning class. It'll be 10 questions, just so you know.
Just some
Okay.
shortcuts.
Just shortcuts. Real simple. I might have one where it says find the derivative at the indicated point, which means you're going to find the derivative and then plug in. And I'm sure I'll have a horizontal tangent one on there. So you're going to definitely want to ask one of those, which is this one right here. All right, 52. So it says find the horizontal tangent. So you get y equals root 3x. I hate that root 3 in front of that x. I prefer the x in front of the root. That's just me, but you'll see it both ways. All right, so here we go. And they limited this. Thank you. Why is it so nice that they limit a trig function? Because if not, you're going to have like infinite number of answers. So since we have it limited in an interval, then we're limited to probably most likely in the unit circle. There's usually just 2 answers, in the unit circle. So it's kind of nice. All right. So let me go ahead and say this. Whenever you want to find horizontal tangents, if you want to write down some steps for this, whatever your graph looks like, okay, let's just say it looks like this. I'm not saying it does, but if it did, horizontal tangents is where the tangent line is going to have a slope of what? Of 0. That's why they're called horizontal tangents. The tangent line is horizontal. Okay? Horizontal line. So the slope of the tangent is equal to what? 0. So that right there, if you know that, and you know the slope of the tangent is 0, you're really talking about where the derivative equals 0. So if you want to write down steps for this, there's 3 steps to finding horizontal tangents. Step 1, find the what? Find the derivative. Okay, you can say it with me. Step 1, find the derivative. Step 2, find where the derivative equals what? 0. And then when you get those x values, those solutions, solve it. And then if you want the actual points, plug back where? Original equation. All right, let's try that. First step, step 1. Find y prime. All right, help me out here. Y prime. This is just a linear term, isn't it? So just be root 3, special case. Plus 2 times the derivative of cosine. Negative sine x. Just saying it. I watched Friends last night. I've been watching episodes of Friends. We watch an episode a night because it's on Netflix and don't really watch TV. And Ross is lecturing and he pretends to have a British accent. Have you seen that episode?
I've seen that.
Yeah, and I'm just like, okay, well, I'm just gonna randomly throw in random accents. So I started saying things weird. It's because I've been watching too much Friends. All right, so once I get to this point, I'm gonna take. I'll clean it up just a little bit. Not that there's much to clean up here. Put the negative where? So it'd be minus 2 sine x. And people keep asking me, do I have to do that? Yes, you do. So don't ask me anymore. All right, second step. Set y prime equal to what?
0.
Y prime equal to 0 and solve. All right? We're going to have 0 equals, oh, here we go, unit circle work. By the way, Max, we are the masters of unit circle here at Perp High School. But you're probably like, well, that's the unit circle. Do y'all learn the unit circle?
Yeah, but not very well.
Okay.
I know it.
All right. So what do we do now? Subtract root 3 and divide by what? So what are you going to get? We'll end up with sine x equals what?
Negative root 3 over 2.
Thank you. Positive root 3 over 2.
Why? Oh, yeah, never mind.
Okay? Because you move that over, it becomes negative, and then divide by negative becomes positive. Or just move the negative 2 sine x over and then divide by 2. Whatever. All right, now, unit circle in reverse. Okay? Put the car in reverse. We'll stride backwards.
Oh, sorry.
All right. There's 2 places from 0 to 2 pi where sine is equal to root 3 over 2. 5 over 3 and
2 pi over
2 pi over 3. Very good. Pi over 3 and 2 pi over 3 are the two places. Because the reference angle, you're looking for a sign positive. That's quadrant 1 and what? 2, and then that'd be pi over 3 and 2 pi over 3 with your reference angle. Now, yes, this is the part that's probably like, I'll just do one of them. I'm not going to do both. But it said find the points. You're supposed to do this on the AP exam. They always make you do this, especially on free response. You always have to plug back in the original to get the points. So you got to plug both of these back into the original. Here's what it looks like. I'll just do can I just do one of them? Just for interest of time. We have y equals, it'll be root 3 times, I'm using the original, okay, times, pi, ooh, that's ugly, pi over 3 plus 2 cosine of pi over 3. Is that going to drag on that? Boards, bouncing. Alright, so then we're going to have y equals, so this would be,
Root 3 over 3. Root 3 pi over 3.
what?
Yeah, root 3 pi over 3.
What?
Yeah, just multiply it out.
Yeah. Okay, I'll tell me something I don't know.
No.
Okay, then was I doing it right?
Yeah, probably.
Was this what you're saying?
Pi over 3 over 3.
Yeah, okay.
Yeah.
Plus 2 times, what's cosine of pi over 3?
It's, yeah.
1/2. And then what happens to 2's? Cancel, so we're going to get pi root 3 over 3 plus 1. I am okay with that answer. What did the answer in the back of the book do? Or the answer I gave you? Stupid common denominator, which is what? 3. So it'd end up being pi root 3 all over 3 plus 3. Now, here's how you write the final answer. Final answer then is a point. It's pi over 3 comma this thing. Pi root 3 over 3 plus 1. You don't need to find a common denominator for me. Just leave it like that. And then you do it for the 2 pi over 3. Does that make sense?
When we find a problem,
Huh?
it's like multiple choice.
Oh, step 1, find y prime. Step 2, set it equal to 0 and solve. Step 3, locate your points, which is original. All right, last one, and then I'm going to show you the alternate form of derivative, and then I guess I don't want you out of here. 47. Ooh, she asked a good one, because this is factoring. Okay, so we got y equals x to the 4th minus 8x squared plus 2. All right, well, first step, y prime is equal to 4x cubed minus 16x. Is that good? Second step, set y prime equal to what? 0. So we're going to have 4x cubed minus 16x equal to 0. Factoring is your friend. If it doesn't factor, here's going to be your two options, and I'm going to review both this week. One is going to be quadratic formula. Second is going to be synthetic division, your new best friend. Okay, how many of you remember synthetic division? A little bit, right? You draw the box and you do the numbers. We're going to review that this week. Okay, 92.4% of the time it's going to factor. Okay, you can quote me on that one. So, how does this factor? First of all, what does it always have to be set equal to factor it? 0. Same thing with quadratic formula, same thing with synthetic division. You got to have it zeroed out. It's kind of like in chemistry class, you have to zero out the scale first before you can weigh anything on the balance scale, Dealio, or whatever it's called. All right, so factor out an x, so we get 4x. Ooh, I can factor out actual what? 4x, and that'll just make it a little bit nicer. So then we get x squared minus what? 4. So then this will be, you're going to have 4x equals 0. This you can factor into x minus 2, x plus 2, or you can solve it with square roots. I really don't care. Whichever way you want to do it. I always solve it with square roots, so it's just going to be x equals what? Plus or minus 2. And then this one, when you divide by 4, you'll get x equals 0. Then you'll take your 0, your positive 2, and your negative 2, and you'll plug it back into the original. So you'll have to figure out what y of 0 is, what y of 2 is, and what y of negative 2 is. Just plug into the original. Y of 0, I can do that one for you. It's 2. Because it'll just be the constant. Y of 2 would be 2 to the 4th minus 8 times 2 squared plus 2, and whatever that is. And then, what is it, 16 or negative 16 or something like that? Does anybody know what the answers were? 2 was the 16? Was it?
Actually, no. Oh, yeah. One's going to be positive.
What ifs? Let me show you real quick, and actually we'll get done a little early. We can get done a minute or two early. Today in class, here's what you're going to do since my child threw up a boot. All right, here's what you're going to look at today. Write it down real quick, and then you can watch the 22-minute video, and this is going to make a little more sense. It's called the alternate form of a derivative. Alternate. You guys are going to love that you would do this morning. You guys are going to ace the quiz tomorrow. I promise you, your quiz is going to be exactly like that homework assignment. If you know how to do everything on the homework assignment, you're good to go. Okay, alternate form of a derivative. You ready? New form. We already have one. What was our definition of the derivative? What was our first definition of a derivative? It was limit as h approaches 0 of what? Fx plus h minus fx over h. That's one form. There's actually a couple of different forms. There's actually another form you can do. This one's the most popular, and it's used to prove differentiability, which we'll get into today. And what it does, this one over here, when you did this one, it gave you the slope of the tangent for all x. It gives you the slope of the tangent for all x. It gives you the instantaneous rate of change for all x. This one doesn't. The alternate form of the derivative gives you the derivative. It is a derivative. Ready? Really cool. At a point. It only gives you the derivative at one point, which is how you're going to prove differentiability for points, which we'll get into today. And differentiability will make sense after you watch the video. So what it does is it's the limit. It's not h approaches 0. It's actually x approaches c. So what it's going to do, it's going to prove the derivative at a specific point, and we're going to call that point c. So it's going to say, hey, we're going to find the derivative at c. So everybody say it. We're finding the derivative what? At c. So maybe that's a 2, maybe that's a 3, maybe that's a -4, maybe it's a -5. You're finding the derivative at a specific point, at a specific x value. So you're finding the slope of the tangent line at c. You with me? And here's what it looks like. It's actually really easy to use. F of x minus f of c over x minus c. And I'll do one example and then we'll call it good. And then at least you have a little bit of a... Now, you look at it and you kind of look at it and you're like, kind of looks like slope, doesn't it? y2 minus y1 over x2 minus x1. And really, just proof by picture real quick, if you think about it, and you have a graph, and you have c here, and so you have a point, and I want to find the slope of the tangent line at that point, and you just think about x being anywhere, so let's just put x right here, and you say, okay, so as x, as that point right there, as it approaches c, what is it really approaching? First of all, if you find f of x, so here's the point, just real quick version. And some of you will see real simply that, oh yeah, that makes sense, that's slope. Think about it. F of x minus f of c over x minus c, isn't that just the slope of the secant line? And then if you let this x value approaching c, it's really like h approaching what? Think about it. If I let that distance between, if I let this x value approach c, what am I letting the distance between them be? I'm letting them approach 0. It's like h is approaching 0. I'm just saying, I'm going to make that x value approach that constant. So if I do that, that point is going to get closer and closer to what? To that point, and that secant line is going to eventually become the what? Do you see how that works? So it's just the alternate form of the derivative. Let me do one example. I'll do a simple one. Let's prove. Let's find f prime of 2, 4. We'll do just a line. F of x equals 2x minus 3. Now, let's just shortcut it real quick and let's see what the answer is supposed to be. What's f prime of x? 2. So then what would f prime of 2 be? 2. Alright, let's see if the alternate form of the derivative works. So the way it would work is be the limit as x approaches, what do we want to find the derivative at? 2. So be the limit as x approaches 2. So far so good? So whatever this c value is, that's the derivative at the point. I want to find the derivative at 2. All right, then it'll be f of x. What's f of x? 2x minus 3. Minus f of c. What's f of c? That'll be f of c will be f of 2. So you got to plug 2 into the original. So that'll be 2 times 2 minus 3, which is going to be 4 minus 3, which is what? 1. Okay, so minus 1. Over x minus 2. Just follow the formula. How many think that's pretty easy? It's easier than this one, isn't it? I think so. It's just f of x minus f of c over x minus c. Here we go. Limit. X approaches 2. You can't plug 2 in right now because you get 0 where? Denominator. So let's leave the denominator alone, x minus 2. Watch what happens on top. Tell me what happens. This is slick. And that with 2x minus 3 minus 1, which is 2x minus what? 4. Now tell me what you can do. Factor out of what? 2. Factor cancel. You factor out a 2 on top, you get x minus 2 in parentheses, and on bottom you get x minus 2. What happens to those x minus 2? It's glorious. Now you got the limit as x approaches of 2, which is what? It found the derivative at x equals 2. There was the answer. It found the derivative at x equals 2 for you. So whatever this x value is approaching, it's finding the derivative at that x value. That's the alternate form of the derivative. And I'll use it today to do differential. There you go. 1 minute done. You guys get extra credit, and for those who took your extra credit quiz, thank you. Day 1 of the grind is on.
You have these grinds once a week.
Yeah, and then in March and April we do it like 2-3 times a week. But that'll be after basketball stuff.